right, good afternoon, everyone. So the recording has started. So today is March 8th, 2023, and we are going to begin our initial discussion on SQL, or you might hear it sometimes referred to as SQL. Both of those are acceptable ways to say this programming language. But first, as I often do, okay, let's start with a quote. And today's quote comes from Sherlock Holmes, a character written by, some of you probably know, by Sir Arthur Conan Doyle. I'm sure all of you know who Sherlock Holmes is, right? But he stated that once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. Okay, so sometimes we arrive at truth by eliminating what is not possible, right? So unfortunately, these days, because of current circumstances, it is not possible for us to meet face to face. But hopefully, hopefully we can still get a good education going through technology, which we fortunately have. So one thing that I do want to announce here early before I forget, due to an appointment that was made months ago before course schedules were set and before earthquakes and other things that I have to be at tomorrow morning, means that I will likely not be available in time for a class to meet tomorrow. So I hate to have to cancel a class this early in the semester, especially since it's going to put us behind a little bit. But unfortunately, it's what I have to do. So we will not be meeting tomorrow morning. You'll have the morning off. You'll notice that, if I'm correct, let's see, let me make sure. I intended to set the assignment due towards the end of that class. Let's see. Actually, the assignment 1 is due tomorrow at 1:30 p.m., which means that you not only have the entirety of this class time where we normally would have been meeting, but you also have the lunch break as well before it has to be turned in. So there shouldn't be any reason that you are not able to get this assignment completed and submitted on time. Okay. All right. The slides. All right, so we're going to talk about the importance and purpose of SQL. How did it come about? How to retrieve data. So we're going to use SQL to do a lot of things to retrieve data. Okay, one thing that you're going to hear me say a lot in this semester is, one of the things I want you to learn is how to let the database do database things, and how to let the front end or the user interface do the user interface things. Okay. Sometimes we try to put too much of the work on one side or the other, and it can cause problems, inefficient code and stuff like that. So you'll see here that how to retrieve data, there's a lot of sub bullet points there. That's because we probably use SQL to get data from a database way more often than we manipulate the data in the database. And because of that, we're oftentimes going to need to use the database side of things to determine what information we get, what data do we get. Okay, there's a big word I'm going to say. It's called delegation, or how to delegate responsibilities. A good company will know how to delegate things. So, for example, teaching this course, right? I am teaching this course, right? Now, could Meli Hoja or anybody else in our department also teach this course? Of course. Have the ability to teach this course, but they have delegated that responsibility to me, right? So they don't worry, they don't concern themselves with these things, right? Or if you hire to the rector, right? Those guys, those people do not teach this course, right? They don't concern themselves with small things like grading of your assignments and your exams and stuff like that. They delegate that to me, right? In the same way, some of you messaged about homework assignment, how to turn it in. I made about that, but I definitely want you to know that I am also delegating. Doruk will be doing a lot to make sure he gets your assignment submission, and that when he grades it and returns the grades, any questions you have are directed to him. Okay, so in the same way, I guess that's kind of like acting like a database. And so where I was going with that is oftentimes things like what we're going to see is sometimes we can make really inefficient systems by trying to have SQL queries. Okay. All right, so it's probably more about that than I intend. Preparing you to hear the words, let the database do the database things. I'm going to say that quite frequently. All right. Another thing that we do have in SQL, ways to update information, to insert, which is how we're going to add data to the database, update, which is how we're going to change data in the database, and then finally delete, which is how we, as its name implies, we're going to remove data. From a little bit of background, okay? So what are some reasons that we created SQL in the first place, right? We want to be able to create database, the tables and relations and the structures and the views, right? So we want our language to be able to do that. We want to be able to retrieve data, insert, modify, and delete data from the database tables, right? And we want to be able to perform both simple and complex queries. All of these things can be done by SQL, right? We want to be able to perform these tasks with minimal user effort, meaning we don't want our users to have to learn the language in order to do it. So we must have ways that we can have our code, their user interface rather. The problem though is that if you just take a programmer. So yes.
I think there's a problem with your connection.
Oh, is my internet slow? Let me see something. One second, let me go check something. It might be the door. Okay. Is that any better? Okay. One more thing. Still, is that still doing? It's still doing the same thing, isn't it? All right, hold on. Let's see. Well, all right, let me try closing out some of these things that might be hogging. now? Are we better off? Okay. One more thing. I'm just going to close out everything on this computer that's using this. Okay. All right. Is that better? Does that work? Yeah. Okay. I closed the camera. I turned off the camera. I'm going to assume that you really meant that it would help the internet speed, Kershot, and that you're just tired of looking at me. Okay, I'm going to hope that that's the case. Okay. Okay. Well, then I guess, well, I didn't have to dress up for today then if I'm just going to turn the camera off. Okay. Let's try again. Okay, so I don't know how much of what was said that was not heard very well. So delegation. Okay, so I talked about how, okay, this was the slide we were on for that outline. Basically, what I was saying was I wanted you guys to know that we do the database things, right? And so what we want to do is we want as much as possible our user interface doing things that we could let the database do if it makes more sense for them. So I don't have, do I have a whiteboard? We'll get to it. Actually, I'll get there. All right. I did also mention that in addition to getting data from the database, we do have SQL queries we can write to insert, which is to add data to the database, update, which is to modify or change data in our table, and delete, to remove data from the table. Okay. All right. So we want to be able to create the structures in a database, like the tables and the views. We want to be able to do those things I talked about in terms of getting data, adding, modifying, and removing data. We want minimal effort, meaning that we want as little as possible for someone to have to learn a new way of doing the language. Okay, so for example, if a programmer comes in knowing Java, well, great. If the syntax could be Java, that'd be great. But the problem is not all programmers know Java, right? Some of you know Python, some of you know other languages, right? So maybe if there was another language we could think of that would be something that many of us know, and we could do the syntax as close to that language as possible, that could be minimized. And finally, we want it to be portable, meaning just like Java is portable because we create the class files and we can move the class files around without having to have the source code. We want the SQL, we want the database language to be portable as well. Okay. So SQL is has two major components: a data definition language for creating the structures of the database, like the tables and the views; a DML, which is a data manipulation language for getting and modifying the data in the database. Okay. Basically, up until 1999, we didn't have what's called flow control, meaning that a programming language like a C or something like that would have to be particularly written to control data updates and data retrievals, or decisions of the user would have to change the data. So we might be able to give some type of Excel style thing. All right. But one of the nice things about SQL is it can do lots of changes all at once. Like it can manipulate up to every row in the database, up to every row rather in a table all at once. Okay. One of the things that we want to talk about with SQL is that it's non-procedural, right? Meaning procedural means sequential. Okay? So what that means is that in order to manipulate, say, multiple rows within a database, we don't have to go through row by row in order to change a value in those rows, like you would with an array, for example, if you were talking about Java or one of those other languages, right? So it's non-procedural, meaning you kind of just tell it what information you want, and you rely on the database management system to determine how to get it. All right, so you don't necessarily say, I want this row, this row, this row, but not this row, and then this other one. You tell it, I want all rows that satisfy a certain condition. Okay, so for example, here, then in this select query, you'll learn how to write a query like this. You're telling it what information you want, what columns you want. You're telling it where to get those columns from, what table to get them from, and you're telling it what condition you want to be satisfied. So any row that doesn't satisfy this condition, I don't want it. And you rely on the database to do the job of filtering those out. Okay. Okay. Let's see. The standard English words is one of the ways that we, in creating SQL, one of the ways that we make the syntax easier to learn. So very, very basic English words, so that hopefully, you know, it doesn't require a dictionary to understand what you're trying to do. Okay. All right. We're going to kind of skip through the history of SQL. If you are interested in this, you can read this in your own time, but we're kind of, again, because of canceling class tomorrow, I'm going to be putting myself a little bit behind, so we kind of need to speed through some stuff here. Let's get this too. Okay. Now, just like most programming languages, SQL consists of reserved words and user-defined words. So reserved words being like keywords. You may hear me call them keywords as well. All right. So reserved words are like Java has reserved words like int and double and public and static and things like that. Those are reserved words, so we can't use them for other things like column names and stuff like that. Okay. User-defined words will be made up by us, right? And they can be names of the database objects like tables or columns or views when we create those. Okay. Now here is a difference from your other previous programming experience, where SQL statements are case insensitive. Okay, except for literal character data, which means except for characters within a string if we're searching for a string or trying to add a string to a database cell, right? But if you write a table name like, let's see, if it allows me to do this, okay. Okay, so if you were to write this, which by the way is a reserved keyword, by the way, so you can't name your table, okay, but this will be treated the same as this. Okay, so those two will be seen as the same thing. Okay, and everything in between. So you could mix up, you could make this letter capital, this letter lowercase, this letter capital, this letter lowercase, this letter capital, and it would be the same thing. Okay, so this is different from, say, like Java or C or a number of other languages. Okay, all right. Okay, you can make your commands more readable with indentation, though you do not require, they don't require indentation. It's not like Python that requires indentation for certain things, right? So, but for readability, for you to understand what you're writing, for us to understand what you're writing, You should begin each new clause on a new line, and I'll show you some examples, especially as we get into more complex queries, some good ways to make them more readable. Okay, we do start each clause lining up with the start of other clauses, and again, I'll show you that. Yeah, so just these are just some formatting things, right? Okay. Generally, this is not, again, because SQL is case insensitive, meaning that you could write your entire query in lowercase or small letters. You could write your entire query in uppercase or big letters, right? The SQL execution does not care. It doesn't matter. It's just like the compiler in Java. It won't give you what it's not really a compiler error, but it won't give you an error. Okay, but I will say that what this, so these right here, this BNF notation, can't remember what BNF stands for, but I'll look it up during the break. But basically, this is more of a formatting expectation for us to be able to read those things better. Okay. All right, so uppercase letters for reserved words like select and from, lowercase letters for user-defined words like table names and column names, right? This we'll be talking about once we get into the definitions of some of the SQL examples, a choice among alternatives, so like you'll see that in just a moment. Curly braces will indicate a required element, square brackets an optional element, and what's called the ellipses here, the triple dots, indicating an optional repetition. And you'll see an example of that in just a moment. Okay. All right, so literals are constants in SQL statements. So a non-numeric literal, we put it in single quotes. So like this tick, London tick would say this is a string, or what we'll the data MySQL, which we'll be using as examples, does not use the word string for its data type. It uses what's called varchar or variable character. We'll talk about that. Numeric literals not enclosed in quotes. So anything enclosed in a quote is treated as a character string. Things not enclosed in quotes are treated as they are, as numbers. Okay. Make sure there were no questions. All right. So here's an example of a basic select statement. Okay, this is basically the definition for how a select statement is used. Right. So this is not an example of how you. This is not an example you would run, but it's showing that this enclosed in the brackets. This is optional. You don't have to have the words distinct or all, right? But you can, and we'll talk about what those mean when we get there. So you could do a star. We'll talk about what star is specifically in just a moment. Or remember, this pipe means or. Okay. Then you can also have it as a column. Give it an alternative, an optional alias, which is a name we could give that column, or expression. We'll talk about why we might use aliases. You can get more than one column. From table name, might give it an alias. Might with the brackets means optional. Okay. Optional where clause that has a condition. Optional group by clause that has a column list. Optional order by clause that has a column list. Okay. The order here is important, and I want to point out that there's only 4 main parts that are required for a select statement. One is the select keyword. We must be telling the execution, we must be telling it that we are getting data from the database. So select, right? We must have one of these, whether it be star or some list of column names or expressions. Okay, so we must have one of these two. We must have from. We need to tell the select statement where is it getting the data from. And we must have at least one table name. Okay, notice this optional part is additional tables we may add to our select statement, but we must have at least one table name. So the 4 parts that are required: select one of these, from, and table name. And as we'll learn in later lessons, table name, it's a bit of a misnomer. This, because it could be a view. We could be getting this from a view also. That is possible. Okay, but basically, before we get to views, let's talk about these. Okay. All right. So again, only the select clause and from clause are mandatory. They must have what are we selecting and where are we getting it from. Yeah, this is kind of telling us what these different keywords mean and what that part of the query means. Okay, now let's look at an example. Let's look at a couple of examples. Okay, so we're going to get all columns, all rows from a table. So we have a staff table. These are the 9 columns that are there. Okay, so we can either list out the columns that we want, so all of them: staff number, first name, last name, address, position, sex, date of birth, salary, and branch number. Or we can do star. Star means all columns. Give me all columns. Okay. Now we'll get into that when we get into example 2. We'll talk about a question that often comes up in this class. So this would be the way that it would be displayed. So the way that it would be displayed is it would give me the columns in the order that I asked for them. Example 2, we want to specify. We want only certain columns. We don't want all columns, right? There's a lot of information here. We don't want all of it. We just want their staff number, their first name, their last name, and the salary. Okay. So when we run this query, we would see only those informations, only those columns we specifically asked for. Okay. Now, I said we would get to something that involves star here. So I have had some students who have asked me, okay, well, what if I wanted all this information, but I didn't want the branch number? So I want staff number, first name, last name, position, sex, date of birth, salary, but not branch number. So I want all columns, but not branch number. Can I just write it like this? Can I just write, oh, okay. Can I just write it like star and then minus branch number, right? Can I just do that? Sadly, the answer is no. Okay, so unfortunately, if we use the star notation, it means all columns. We can't say all columns minus some other column. Okay, so maybe that might be something that one of you, if you want to develop a new version of SQL, that you could add that functionality so that when we say give me all columns, but not some specific column, that it could do that. It could generate that query for us. And so I'll leave that up to one of you guys to develop the next version of SQL, right, so that we can get that going. All right. Okay, so again, that's the way that would come out. Okay. Now, sometimes if we were to run a query like this, select a single column from a particular table. So select property number from viewing. Okay. We might see something like this. So it's going to give us every row in that table. It's going to give us that column for every row in that table. Okay. What do you notice in this? What do you notice in this particular thing, in this particular result? Yeah, there's duplicates, right? PA14 shows up twice. PG4 shows up twice, right? So sometimes, especially if this table were thousands or maybe millions of rows, we might not necessarily want to know. We just want to know what properties were viewed, right? We don't want to see PA14 multiple times. We just need to know, is PA14 in the table or not? We just need to know, is PG4 in the table or not? Do we just need to know if some other property, PB26, is it in the table or not? Right? We don't necessarily need to see how many times. We just want to know how many. We just want to know whether a property was viewed or not. Right? And so we can use the distinct keyword to say, only show me this column on this table, but only show me a result one time if it appears at least one time. Okay. So now notice there is some information missing here in that we don't know how many times PA14 was viewed. We don't know how many times the other properties were viewed. We only know that it was viewed at least once. Okay. So that's all we know from this result, but that might be all we need to know. Okay. In fact, that brings up another piece of advice from me. When doing these things is know the question that's being asked. If all I need to know is whether or not a property was viewed or not, I don't need to know how many times, then a query like this would serve me quite well. Right? If I needed to know how many times it was viewed, there's another way we can do that, and we'll talk about that. Okay, but it reminds me of an old problem, the old riddle. If you've ever heard of the the riddle of the two doors, where one door leads to certain death, and one door leads to a wonderful prize or a great treasure, and there are two guards at the doors, and one guard always tells the truth, and one guard always lies, right? And you are given the opportunity to ask one question to one guard, and based upon that question and that guard's answer, you choose which door to go behind. And the question then is, what question should you ask? And then based on the answer, which door should you choose? What question can you ask to one guard in order to make sure that you get the treasure? All right, it's an old riddle, and the shouldn't say the, but a correct solution to that riddle, a correct answer to that riddle, basically depends on us not needing to know which guard is telling the truth and which guard is lying. All right, that's information that we actually don't need in order to solve the riddle. So if you've never heard of that riddle, we can talk about it later, or I can probably find a YouTube video to it somewhere. And it's an interesting, I like riddles. So that's the point I'm trying to make here is make sure you know what information is being requested and don't necessarily feel like you need to get more than what is requested. Moving on, we can use mathematical, or what we'll find out later is string as well, or character expressions as well, to be able to calculate a field. Okay. So here we want the staff number, the first name and the last name, and salary divided by 12. Why do you think we need to divide salary by 12? What are we trying to find out here? Right, monthly salary. Most likely our salary in our database is stored as a yearly salary, and so then when we divide by 12, we find out how much they are making monthly. Okay. So when we run this query, we'll see that information, staff, name, staff number, and their names, and then this. Now notice here this call for. heading for here. Not every database management system is the same. Some DBMSs will actually put something like salary divided by 4 here. I think MySQL does call for. I think Microsoft Access does EXPR with a number, so it does like EXPR for expression, right? So it'll replace it with something like this. This will become very important in just a moment as on the next example, because we can call it example 4B, because what we can do is we can give that that column a name. Okay. So we could say staff number, first name, last name. Give me the salary divided by 12 as monthly salary. Now there's no grid here for some reason, they didn't include it. But when we run this query, instead of seeing call 4 here, we will see monthly salary. Okay. That can be very helpful as we want to reference the result in maybe a user interface or something like that. We want to give it a meaningful name for our code that's going to use the results of our query. Notice, I want to make sure you're clear about this too, is that monthly salary name, that's not a column in the database. Okay, that column does not exist in the table staff. This query doesn't make that column exist in the table staff. Right? It only makes that column as the column name for the result of this query, so that when our code or when our user runs this query, that's the column they see. That's how they reference the data in that column. Okay. Let's see. Okay. Moving on, example 5. Let's say we want to limit the number of rows. So far, what we've looked at as examples are we get all the rows in a table. Okay, we haven't said limit how many rows I get. We said I want to see all the rows and all the columns. We've said I want to see certain columns, but all the rows. We've said I want to see a certain column, but eliminate all duplicates. All right, and we've said I want to see all the rows with one of the columns having some type of mathematical expression with an alias. This example is going to say, okay, I want to limit the number of rows I get. So I only want to see the rows where the salary of an employee is greater than 10,000. 10,000 what? I'm assuming based on today's economy, and that's a yearly salary. That's probably not lira, but could be. All right, so we're going to see what is someone. I want to see every person in the staff table who has a salary greater than 10,000. All right, so here we will get only results where the salary was 10,000 greater than 10,000. Notice that this is strictly greater. This is not so anybody that has a salary of 10,000 will not show up. In fact, let's go back and look at some of the previous data and see. And now that's a. Is there anybody that had 10,000? Okay. Well, here's some examples here. Mary and Julie, they both were less than 10,000. So we would expect them to not show up in this result, right? Right. Yep. So no Mary, no Julie. Right. So here we're just seeing the results where the salary is greater than 10,000. We can also do comparison searches. So we want to get all the branch offices where the city is London or Glasgow. I don't know how to pronounce this city name. I'm not British. And every time I pronounce it, I think my British friends laugh at me. So we can say where the city equals London or, notice not the double pipe, okay, not a symbol, the word or here, city equals that thing. Okay. So here, the city is one of those two. So we're not seeing any branches from other cities. So we can also do a range. We can say get this information from staff where salary is between this value 20,000 and 30,000. Notice here, unlike the one we looked at before with the greater than symbol, the between test included both the endpoints. So we're going to get 20,000 showing up, but we don't have anybody in that. And we're going to get 30,000 showing up, and we do have someone there. Okay, so between would be the same as if we had said greater than and or equal to than the lowest part, and salary is less than or equal to the highest part. Okay. Also, we can have a negated version, right? Not between, where it would be outside of the range, okay? Where it would be less than 20,000 or salary is greater than 30,000. So it would get anyone outside of the range, okay? Now, now you're going to see this showing up a few times in descriptions about some of the SQL options we can do, where it says it does not add much to SQL's expressive power, meaning that we already had another way to do this. We could have just set it up using the greater than or equal to this and less than or equal to this, right? But for some people, myself included, it can be easier to understand this, right? It can also be quite frustrating or tiresome to have to write the word salary twice like this, especially if for some reason if the column name changes. So maybe they change it, maybe they change it to a monthly salary, right? Or they change it to some other column name or something, right? Then having to change it one time as opposed to having to change it 2 times for every where clause can be quite frustrating. Okay, it can be quite frustrating to have to change it twice. All right. Let's at least try to get through example 10 and then we'll take a break. Okay. Oh, listen, emergent selecting all the something like star divided by 2. Like star, like select star divided by 2. That would, you can't do that. You can't do any type of mathematical expression or other on a star. And even if we could, that would probably require that every column in the table be the exact same type, or sorry, or be like all numeric, which is, gosh, I can't even remember I can't ever remember seeing a table where every column was the exact same data type. So it's a good question. If I'm understanding your question correctly, then that's my answer. If not, let me know. All right. Like I said, let's try to finish up example 10 if we can. All right, set membership. So we're going to get these 4 columns from the staff table where position is in one of these 2. Position in manager or supervisor. So we treat this as a set. Manager, supervisor, position needs to be one of those values in the set. Okay. So notice we're going to get only the results where that's the position. Okay. Again, this is the same as position equals manager or position equals supervisor. Okay. It does not add much, like I said. We already had a way to do this, but again, what happens if we want to add a new thing to the set? Then we have to add an or, column name equals value. Whereas with the previous version, we can just say comma new value. Okay. N is more efficient when sets contain many values, so it becomes not a whole lot of position equals blah something, position equals blah, position equals position equals position equals. Instead, it's just position in a particular set. You know, actually, this is going to require a bigger discussion than I realized. So we're going to take our break here. Actually, I've given you a lot of new information here, and we're going to start off the next part of our discussion with pattern matching because it's a much larger discussion than I have time to finish in a few minutes. So, okay. All right, so let's take our break. I'll see you guys back here again at 2:30, and we will pick up where we left off.